All right, in this lesson, I'm going to go over the perpendicular chord bisector theorem and its converse. If you were in class for this CLT, we had a chance to actually prove this for about 15-20 minutes. So anyway, this is the summary of that, formalizing it in a sentence. This will be on the formula sheet. So if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So kind of the key thing is if I'm looking at this diameter, right, we see that 90-degree angle, so perpendicular, and you'll notice that these two segments of the chords, or of the chord, excuse me, they're going to be the same. Okay? All right, so let's use that with some of these practice problems. All right, so number one, you'll notice that we have this right angle symbol, right? We have that diameter going through the center. All right, it's not drawn all the way, but if you wanted to draw it, you could. All right, so we know that this x and this 17 must be the same. So x is equal to 17. All right, those are the same. Now, something that is not on this question that I'll show you is, we'll do some of this later, but if you draw another radius there, and we know that's a right angle, right? We know that the radius based on this figure is 20. So I could write a 20 here for that radius. And if we know this is 17, we could find that distance from the center to the chord, right, using Pythagorean theorem. Right? That's definitely going to come up. So I just want to show you that there are different variations of this problem that are more challenging. Okay, number two. All right, so kind of a similar figure that we just had there. We have that right angle. We know that this and this are going to be the same, so I'm going to write an x over here. So we have three sides of a right triangle. We have, two of them that we know. We can find the third one. So a squared plus b squared equals c squared. So we have, I'll do x squared plus 4.1 squared equals the hypotenuse 11.9 squared. All right. Now, with this kind of problem, I would expect you to use a calculator. All right. So we have 4.1 squared, which is exactly 16.81. Equals 11.9 squared, which is 141.61. I'm going to subtract that 16.81 to the other side. So do 141.61 minus 16.81, which is a 124.8. But remember, that is not going to be the value I want. I do need to take the square root of both sides, which will give me, so the square root of 124.8, which is 11.2 approximately. All right, so this value for x is approximately 11.2 units. Okay, all right, let's try number three. Okay, so number three, very similar type of question to number two, but this time the one we're looking for is actually the hypotenuse, right? This right here is hypotenuse. So I'm going to do a squared plus b squared equals c squared, where we have 10 squared plus 13.8 squared equals x squared. I know this one is 100. I don't know 13.8 squared, so we can get that one for us. 13.8, ooh, good try. 13.8, there we go, squared. 190.44 equals x squared. Add those together, you get 290.44. We'll take the square root of both sides to give us x is approximately, we'll take the square root of that. So the square root of 290.44 is approximately 17.0 units. All right, so that's it for three. Let's look at four. All right, so four uses that same understanding where if we have this diameter, right, intersecting that chord and creating that right angle, so they are perpendicular, then this part of the chord, right, and this part of the chord, they're going to be the same. So if that's 8.9 over there, then this is 8.9 over here. All right, again, using Pythagorean theorem, we can find this value for x. So a squared plus b squared equals c squared. This time I'm solving for a leg, just whichever one you want for a or b. X squared plus 8.9 squared equals the hypotenuse of 9.4 squared. So So we got 8.9 squared. 8.9 squared is 79.21 equals 9.4 squared, which is 88.36. Move that over, right, which is going to be, is that going to be 9.15, I believe? Confirm. Yes, and then I'm going to take the square root of that to get my answer. Square root of 9.15 will be approximately 3.0 units for x. So approximately 3.0 units, and I took the square root of both of those. Okay? All right, let's keep going. We're almost done. 2 more to go. Okay, so we have these two. We got a challenge one at the end. All right, these are going to be harder, kind of like the ones we just had on our recent test, where you had to take a word problem and draw out what's going on to eventually have a right triangle to use SOHCAHTOA. Obviously, that's not happening here. We're not doing SOHCAHTOA, but we are going to draw a circle. And it says we have a chord, so I'm going to draw a chord. And that chord, highlight it like this, is 24 units long. So that chord is 24 centimeters long. Okay? It says the distance from the center of the circle, so there's the center of the circle, to the chord, so this distance here, so I'll highlight that as well. So this distance, right, is 5 centimeters. So that distance is 5 centimeters. All right? Find the length of the radius. So we know that if we're drawing this center of the circle to the chord, if I were to keep going, that would be a radius. And if I went the other direction, I would draw that diameter. And we know that we have a diameter and a chord. They are going to bisect, so create that right angle. All right, and so that's going to split this 24 into 12 centimeters over here and 12 centimeters over here. All right, this little guy here is 5 centimeters, and I'm trying to find the radius. Now, if I draw another radius that intersects over here at this point, right, I can figure out that radius using my understanding of right triangles, okay? So I'm going to write a squared plus b squared equals c squared. I'm solving for the hypotenuse this time. So 5 squared plus 12 squared equals c squared. Now, I was hoping you guys would know this one. We talked about this a while ago, but if you don't recognize it, that's okay. So when you sum those squares, you get 169, and the square root of that is going to be 13 units. And we do have a unit here, so the radius is 13 centimeters. Okay? All right, let's do our last one, this challenge, the optional one. It says an equilateral triangle with sides of length 10 is inscribed in a circle. So draw the circle. All right, and I'm going to draw an equilateral triangle that's in here. So I'll do my best to draw the equilateral triangle. It says every single side of this, since it is equilateral, is going to be 10. So each of these is 10 centimeters. Okay. And then it says that we have find the distance from the center of the circle to the side of the triangle. So I'll just draw it down here to the side. Now, hopefully you remember that if I were to keep going, that would be the radius. If I were to keep going this way, I'd make it the diameter. So I have that right angle. Okay, which if this base of this triangle is 10, that means each of these are going to be 5 centimeters. All right, and then I'm trying to find, I'll try to highlight it again for you. I'm trying to find the distance from the center of the circle to the side of the triangle. So this is what I'm trying to find, right? That's my question mark. All right, and if I draw, just like I did before, if I draw one of these here, right, another radius, you should hopefully remember that each of these angles in an equilateral triangle is 60 degrees. So if I take this radius and draw it to bisect that, then each of these is going to be 30 degrees. And so basically what this becomes is a 30, 60, 90 right triangle that I can use to find this side here. Okay? So if you look, they're giving us the long leg because it's across from the 60 degrees angle. And I'm trying to find the short leg across from the 30-degree angle. So hopefully you remember from your most recent test that I can move this direction and divide by the square root of 3, okay? So I'm going to write 5 over the square root of 3 will be the distance from the center of the circle to the side of the triangle. I'm not going to leave it like that. I'm going to multiply by the square root of 3 over 3 to get 5 root 3 over 3. So the distance from the center of the circle to the side of the triangle is 5 root 3 over 3. Does it say centimeters? I just made that up. It says 10. Okay, I'll say units. Sorry about that. I made up the centimeters, I guess. All right. Okay, guys, so that's it for this. Check out the key, check out the homework, and come see us if you have any questions. Good luck.